Hey guys, so this video is going to be modifying a vintage heater to make it more usable for modern situations, just making it more reliable and trust it more. Um, we got like 3 of these heaters here, and I just recently got this one at like a yard sale, and it's practically looks new, like it's never been really used, and I did try it out and it works, but there's 2 reasons I want to replace the cord on it. One, obviously it's old, and these are known to heat up. Like you can actually see on the prongs here, as you can tell it's just been hot, so that's obviously not good when you see that. If you look at the writing on the cord, it's a 16 gauge, which is good for about approximately like 12 amps, I believe. Standard 20 amp circuit is usually wired with the 12 gauge wire. It's supposed to be if it's on a 20 amp breaker. If you do the math, 20 amps at 120 is 2400 watts. So standard 120 volt receptacle is rated for 2400 watts. Standard heater like this is 1500 watts. If you divide it by 120, you get your amperage of what it actually draws. So it draws approximately 12.5 amps. That's on the high setting. You do have 3 settings on it. So 16 gauge, obviously it met the specifications for it at the time, but these do get warm. I just never did trust them, leaving them on for a real long time. You can definitely tell that plug's been hot a time or two. And I question if it's even 16 gauge just because of how flexible it is. And I just never did trust them. And the second reason, obviously the whole heater is made out of metal, and it's a 2-prong plug. So if a hot wire got hot or something, touched the side of the case, instead of shorting it out and kicking the breaker, you now have 120 volts on the frame of the heater. So anytime an appliance is made out of metal, I never like to see a 2-prong cord just for that. Now if it's plastic, like 90% of things made today, plastic housing on something, and you don't, this is all you need because there's nothing to actually ground. But anytime you got like a metal case like this, I like to see a 3rd prong. So we're going to take it apart, and this varies between heaters, so I'm not going to spend too much time on how to take this particular one apart. But it does appear to have a cover on the back. It just comes out with some screws. That should give us full access to the wiring. We can also inspect the wiring too, make sure there's no cracks in the insulation or any other potential problem while we're in there, just so we can trust the heater more. I rarely ever use these space heaters. I got a gas heater in the garage, but sometimes you just want to plug in a heater and just feel the heat from it. So it's good to have that, and also as a backup, my generator will run this if for some reason the gas is out and the power goes out. I can fire this up and take the chill off. So let's get this back cover off. Take these screws out. Alright, so this has like 6 screws holding it on, about 5 screws. So we'll go ahead and pop this loose. Also, another problem I run into is bugs like to make nests in appliances like this. Oh, this thing's mint. This thing is like brand new inside. Not much of a fan in these. I'll go ahead and put a drop of oil on that fan too while we got it apart. Now let's get a close-up of some of the internals on this. Like, I know it's just a space heater, but the way things are made, or used to be made, is more intriguing to me than the way things are made nowadays. So you got a pretty standard type electric motor, 2-blade fan. That's typical in play on these. Nothing to worry about there. It does spin free. These are bad about locking up, just from the bearings running dry. So I'll put a drop of motor oil on there, and if I can get to the bottom one, I will on it too. There's a tilt switch on these. That'll shut off if you tilt it over. You can see that wire's been hot there. Some of the insulation's burnt off, which I'm not too worried about because it's inside that insulator anyway. It is just something to note that, these things run hot. This is the old type that actually glow, so we'll test it out here at the end. But we just got to trace the wires out and splice into them. I'm not going to go into too much detail on this. Here's the selector switch. That'll be the hot wire going towards that switch, because you always want to break the hot, not have a hot on one side. So let me just kind of, most of this is going to be done off camera. Just kind of wanted to show you what to do and reasons why and things to look for. But this thing looks like it's brand new. I'm very shocked it's this clean. I did want to briefly mention something about, I was talking about adding a frame ground to it. It just makes it safer. As you can see, there's nothing like bonded to the frame. So everything, the frame is more or less just a floating ground on this. So the problem could be, if nothing ever happens, if none of these problems ever happens, it'll be fine. You never have no risk of a shock or anything at all. But say this wire right here, perfect example. It just happens to be resting up against the frame of this. If this wire, for some reason, overheated and the insulation burns off of it, like you see it's trying to do up here in this case, so I'm going to move this, try to get it away from the frame before I put it back together. But what can happen, it'll burn through, then you get the wire touching the metal, so then if you touch this, it's 120 volts to ground. So that's just something to watch out for. That's a perfect example of what can happen though. So I'm going to try to probably zip tie all this over out of the way a little bit, make sure the fan don't hit it or something, So you just bend it right there, got it away from it, so that should be sufficient right there. Alright, on to the wiring. And these wires hook directly to everything, so I'll probably just splice into them. It's the same type of wiring that's used inside here, so it'll be fine. And one other note to mention, make sure that this is unplugged while you're working on it. You'd be surprised how many people get shocked when working on something and realize it's still plugged in. So just make sure it's unplugged. Alright, so here's the cord I'm going to be putting on it. You see it's a 3-prong cord, much heavier duty than what came off of it. One of the biggest causes of house fires and electrical fires is your cord overheating at your plug, which makes all your wiring in the receptacle overheat right in your wall. So this cord here, right there, 14 gauge. So 14 gauges go for 15 amps. This pulls about approximately 12 and a half. So this is way better than what came out of it. A 12 gauge would be ideal, but it's kind of overkill. This came off of probably a microwave. Well, it's kind of long for a microwave. I'm all the time cutting cords off of appliances I find in trash. So this probably came off like a table saw or something like that, I would say. Very nice cord. And I put the screws back on this temporarily. I'm going to drill out this hole where the plastic cable came through. Never was a fan of those. And even though it's not going to look the best, it's definitely going to serve the purpose. I'm going to put this type of cable clamp on there. It's got the nut that goes on the back side. I just got to open that up and probably put it on upside down so the screws don't interfere with the floor. And it's going to be a much heavier duty setup. And that cable's not going to pull out of there once you clamp it down. And just use your step bit to drill it to 7/8. It'll work perfect. So I'm going to have to cut this out just a little bit on both sides, just to make room for the nut, or everything just goes on and don't have to fight with the sheet metal. And also don't forget to get any of your metal shavings out from inside there. Probably took it too far in this case. And honestly, I probably should have drilled a hole up here, but I was just trying to keep the more factory look so you can't tell that it was, modified to seeing where the original connector was. So, it just depends on whatever heater you're working on. You might find a better way to do it. You could even come in the side right here. So I just drilled a small hole here in the side for the ground. You can easily take one of these bolts out of the motor or whatever and find some other ground point without doing this. But I'm using a small 1024 sheet metal or machine screw. I'm also using these star washers on here. That'll help dig into that and get a better bite in the metal for better connection. So I ran the wire through the connector. I got slack in it just to make it easier to set up. Got a ground established over here. We'll ohm it out just to make sure here in a minute. I soldered these on here just to get a very good connection that it won't arc or anything. And I'm just going to put wire nuts on it, be done with it. I'm probably going to have to zip tie everything over here to the side just to make sure the fan clears everything. So don't forget to watch for your fan. Alright, so you got all the wiring tucked away. Everything's locked in pretty good. Got the zip tie right there to the fins. I'm trying to feature a zip tie in every single project I work in because I recently became zip tie certified. I don't know how well you can see the display, but when you touch them together, I'm getting 0 ohms, which is a direct short. So from the ground prong to the frame, 0 ohms to a random screw on it, 0 ohms. So we've got a perfectly good ground connection. So now if something shorts out or something, it'll kick the breaker. Instead of making everything hot on there. See, I cut just a little too much of that out of it. So not only is it safer, but it's also got a longer cord than it used to. It looks pretty good. I'm happy with that. It looks good. Alright, let's plug it in and make sure it works. Alright, there it is. This is a temperature control. This is off, low, which is just one element on low, no fan running. Medium puts another element on, that's on high or medium with the fan. And high kicks all the elements on and the fan. Light's working. No shockage. Works good. Throwing some heat out already. These take a little bit to get going. You'll see the elements start glowing. That's what I've always liked about these. And that fan provides some good circulation. It's not a real powerful fan, but it does move some air. I don't know, these were always my favorite space heaters. Now I got one that's set up to be safe and reliable now. That I can actually trust. If I needed to plug it in and walk away for 20 minutes, I'm not going to panic over it. So I'm going to let it run for a minute. We'll do a temperature test on the cord, make sure nothing's getting warm. Only thing I smell burning is a little bit of dust coming out of it because it's been sitting for several years. So let's check back here in about 5 minutes. Alright, it's going pretty good now. Let's turn the light off so you can see how much it actually glows. Pretty impressive glow. So you get radiant heat from it, and you get air circulation from the fan. So it's a really good heater. Alright, just for some curiosity's sake, let's get a temperature reading off the element. It's 875. Oh, it hasn't peaked. 7,100 degrees. 7,125 degrees. I don't think that. About 400 on the element. 700 is the hottest temperature I found on the element. 946 Fahrenheit. 508 Celsius. It's very hot. Alright, so we're going to unplug it. The cord's not even warm. I was going to check it with the meter, but there's no. It's showing 100 degrees. I'm getting heat off the heater. Yeah, it's like 100 degrees. They don't even feel warm when you touch it, so probably pretty accurate. Alright guys, we'll go ahead and end this video. Hopefully this helps you out. Maybe you're not even working on a heater, you're replacing a cord on like an old power tool or something. You want to add a ground to it and make a heavier duty cord on it, or even just longer. If you don't have a cord like this, you can go to the Blue store, Lowe's. You can get replacement cords with different amp ratings. The cord's also cool, by the way. And worst case scenario, get an extension cord and just cut the end off, and you can make it as long as you want. A lot of options. I recommend just looking for a microwave or something on the side of the road and cut the cord off of it. That's what I do all the time for projects like this. Alright guys, so I'm going to go ahead and shut this off and let it cool down. It's been on for about 20 minutes there and doing good. So I feel like I can trust this heater again. Alright guys, thanks for watching. Hopefully get back on track and making more videos this winter than I have been doing. Hopefully some small engine stuff. I'm just kind of at a standstill on all that stuff right now because I don't really need nothing to work on that I have, and I haven't been buying up anything. So I'm sure I can find something we can work on here soon. Got a couple ideas, so hopefully we'll do a small engine video for the next video. I got a 5 horsepower Briggs, an older one. It's a reservoir inside the gas tank. Gas tank is it's off. I don't know if it's rusted loose. I got to take the whole tank completely apart. So that might make an interesting video. I have to JB weld it back into place, or tack weld it, or something like that. So we'll figure that out as we go. So, well, I'm good and warm now, so we'll go ahead and end this video and catch you all later. Thanks for watching again.